You hire up some chemists and build a factory. Don't break the law. Don't break the law. Break the law. Don't break the law.
What number are we on?
How much reactant do you need to get the product made?
Okay, 10
10?
sounds good. No, well, we did 10. Number 11.
Oh, okay. Number 11, identify the more active reactant in a single replacement reaction. The more active reactant, this goes back to the activity series lab.
Yeah.
The more active reactant is the one that jumps into a chemical formula. It jumps into a compound.
Do we have one? We have an example.
Yeah, here's an example, which is a little bit different than ones we spent probably the most amount of time on.
We've seen this one.
Yeah, they've seen it, but when we did the
The
activity series lab,
yeah.
it was always a metal replacing another metal,
Right.
typically. But here, chlorine is jumping in and replacing bromine. Chlorine must be more chemically active.
This was the Shall We Dance.
Right.
It's all about the dancers, and we know that, you know, the new element coming along must be more reactive. We can kind of estimate if we don't know our activity series by looking at like hollow 1 and 2 metals, which we already know are much more reactive than those transition metals, and you saw that in your lab. So make sure you go over the results of that.
The non-metals closer to fluorine in that upper right-hand corner.
Yeah,
those are easy. Yeah, they're going to be more reactive. Number 12.
Identify the possible products in a combustion reaction. Simple. When you burn something, like a hydrocarbon, you are going to produce carbon dioxide and water.
What's a hydrocarbon?
I think it's something with hydrogen and carbon.
And carbon.
Like our example of methane here, which you use in your Bunsen burners every time we do a lab with heat. And since the weather's getting nicer, you're probably using when you in your gas grill with your propane, another hydrocarbon.
Yeah.
Good?
Yes.
Number
13. 13. Describe the reactants and products in a double replacement reaction. Going back to those on that 11.2 section review sheet.
Yes.
On the front where they have the fill in the blank couple of paragraphs. That's an excellent summary of different reactant types. Reaction types, where you're going to have 2 aqueous solutions of ionic salts produce another aqueous solution of an ionic salt, and usually
a
solid precipitate.
Solid precipitate. There are some that can react and produce a gas, and then we know from our lab 15, our acid and base neutralization, that's another example of a double displacement where our base and our acid produce a simple ionic compound of salt and water.
Right.
Okay. In Papa Podcast, they talk about switching the cation, or the bright surface.
Yeah, they were drawing.
So,
yeah, it almost kind of looked like math, where they do the foil.
Oh yeah.
Right, where they were doing the insides and the outsides.
Right.
Right.
As long as you're not ending up with the 2 positives together and the 2 negatives together.
Yes.
That does not happen in the world of ions.
That's a no-no.
Okay, 14. Yes.
14. Write the balance equation for the decomposition of a metal oxide.
Well, that's metal and oxygen,
So the only way that they can come apart is to produce the elements, the metal and oxygen.
Right.
That's it.
Yeah. So, and oxygen is one of the magic 7.
You got to remember it's diatomic.
Right.
So
it's got to end up being diatomic, and make sure that you're not writing your 2O, you're writing O subscript 2.
O subscript 2.
Then balance your equation. Woohoo, 2 pages down.
Right. Sweet.
15.
15.
Complete a balanced double replacement reaction given the reactants. Love reaction prediction.
Oh, these are about as hard as we can make them, because it becomes a multiple step problem.
Right.
This one should look familiar to everyone. This one came right off of 11.2 section review.
Right.
It was the last question on the bottom of the back, where you were given the reactants,
right,
and then
you had to figure out.
This side was blank. And so this becomes a multiple part process.
Right. So what happened in this again, in this double displacement?
Where
if we didn't have that, when we look at that, what would we look for?
you do your cation from the first and the anion from the second,
Okay,
hook them up,
yeah,
and then you have to come up with the correct formula for that.
okay, and yeah, because you've got to get the subscripts to balance and the charges, you got to look at the charges and everything there.
But remember, when you're doing those subscripts on that part of this process, that's not balancing the equation. All you're trying to do is come up with the right chemical formula in which the ionic charges are balanced, but you're not balancing the equation.
Right, and
So,
a lot of them keep trying to do that.
Yeah, they just want to move this NO32 and make it fit over there.
You know what, they need to go back to the,
Chapter 9.
yeah, so we know zinc is +2. In this example, we know phosphate is -3. You need to go back to what you learned about the crisscross method and taking the charge on the anion, making it the subscript on the cation, and the charge of the cation becomes the subscript of the anion. We would put that in parentheses, and we would write our zinc phosphate, well, like I had down there, ZN3, PO4, with 2 outside the parentheses. So do that step first.
And that is not balancing the equation. So
Right.
you're allowed to manipulate these subscripts here.
Until you get them right.
Once that process is done, and you have the correct formulas of your products,
Yeah.
now the subscripts are off limits.
Right.
And you can't balance the equation by changing those subscripts.
I like, our QR code that we put in the,
To Papa Podcast?
well, it was to a website this time. Our
Oh,
QR
yeah.
code that sent you to a link of a basic description of how to balance, what happened there is they tell you to trap them in a box. Once you get your subscripts written correctly, your formulas correctly, trap it in a box. Don't mess with that. You can only mess with however many you have of that whole compound. So I
Right.
think just get it right, put it away in its little box there,
Right.
and then count from left to right how many of each you have.
Right.
It is going to be really crucial that you do that, especially when we get to the short answer, where you're going to be doing a lot of reaction prediction, and you got to know to get these formulas right. I'd almost want to tell them to do this, go on to another problem, and come back and then balance it, so you're not tempted to
Right.
just try to manipulate subscripts to make it all work.
Right. Those of you who are watching the clock,
Right?
we have spent a long time on this one question.
Yeah.
It's
Because-
important, and it isn't necessarily just important to be successful on this test. This is a great review of Chapter 9.
Right.
And my kids have heard me say this for a long time now. The final exam is on the horizon. It's right out there. This is a great review for Chapter 9. This stuff is only going to build into Chapter 12.
Right.
And a lot of you need to have a good Chapter 12 to finish out the year strong.
Sure.
So pay attention to these kinds of problems.
Okay, number 16.
Yes. 16. Balance a combustion reaction given the fuel.
This one's kind of tricky.
No, it's not. If you know what the fuel is, that's the only thing that really changes in
True.
combustion reactions.
Because
Because the other three things, 99% of the time, are always the same three things. In a combustion reaction, you have the fuel.
right. Plus,
Oxygen has to be a reactant. We
Right.
need oxygen to burn anything. And 99% of the time, you're going to produce carbon dioxide and water.
right.
So whatever this is,
Mhm.
doesn't really change what you produce over there.
Okay, cool. Awesome. And what are we doing next? Oh,
I think
number
it's 17?
17. I think it is number 17.
We'll come back to 17.